first video shows Don Wallinger of West Coast Saws in Tacoma, Washington. Don has been the production manager of several of the very best saw companies in the country. He also was one of the founders of DinoSaw. His technique and ability to train are excellent. The second video was filmed by Russell Hartley, showing Jesse Hartley brazing at Anthony Forest Products in Strong, Arkansas. Both Hartleys are very well respected personally and professionally. They showed their unique brazing setup that they invented, as well as demonstrating another version of excellent brazing technique. Our thanks to all of these gentlemen for sharing their considerable knowledge and expertise.
Yeah, we know the thickness of our saw blade, we know the thickness of our carbide, and we have to center the carbide to the saw plate. So we placed our shims on the table. We put a little circle on here so we can put the plate back in the same exact position. And before we go to all that, we're going to actually flux the blade. Flux is required before we go ahead and do our brazing. So we just put a light coat all the way around, and this prevents burning or bluing of the saw steel. Flux is to protect the silver solder so we don't overheat, and so it flows and bonds to the saw plate. We already know the tip size, and so we're going to go ahead and put tips around the saw blade. We've already predetermined what size of tip that we need for our torch. It's vitally important to know that the thickness of the saw plate and the size of the carbide so that you put the correct tip on your torch and not overheat the carbide or burn the plate. One of the things that we do is we take a look at the thickness of the saw tip and the thickness of the plate. We know that if we use a tip, the larger number on the tip means more heat. The smaller the number means less heat. So we size it according to the thickness of the plate and the thickness of the carbide. Okay. The tip only has so much capability for settling, and you can put way too much pressure on the gauge. It's not necessary to do that. All you need to do is light the torch, open the valve on the settling, that's too much. Leave a little bit of black smoke. Have your oxygen on. Bring the flame down. If the torch is blowing or making noise, it should be quiet. You've got too much heat. Bring it down. It's quiet. If you give too much oxygen, the torch becomes very noisy. You've got too much heat. Close it off. Becomes nice and quiet. But we have a very long pencil point on the torch that's going to be too hot for what we're going to do. So we're going to reduce the amount of settling. Bring it down until we get more black smoke. Open up the oxygen. Pencil point is shorter, it's still quiet. This is adequate to do the job that we're about to do. What's critical is to keep your arms close to your side when you're brazing. Keep the torch pointed away from the center of the blade. Always heat from the bottom of the tip out. You want to heat the back side We want to heat the bottom all at the same time. Bring it up to a temperature not to exceed 1400 degrees.
These are our pre-tin tips, so the alloy's already on the tips.
Solder and bond. We do it in 1, 2, 3 step. We heat the tip up till it becomes a very light cherry color. The plate is about the same color. We move the tip out. As the solder flows, we move it back. We set the tip with our pointer, and we take our heat away. Never putting too much pressure on the face of the tip so it doesn't twist or turn. Now we have too little heat. Solder is not melting. So we give ourselves a little bit more heat. One, two, three.
You move it out to release any gas that might be trapped in it.
Concentrator at the bottom of the tip, along the back side of the tip, so that the steel and carbide heat together. The solder is flowing, and we set the tip. Here we go. Heat it up. 1, 2, and 3. Get our heat away from there. Let the solder bond.
You notice he doesn't push it
After
in.
you remove your heat, because then you'll break the bond, and the tip will also be crooked. Don't continue to touch it after you remove your heat, because then you'll break the bond, and the tip will also be crooked. When you're finished brazing, the flux should still be a shiny color. If it's a flat black, you've overheated it. What's happening here is the flux is expanding when the heat touches it, and it wants to actually move the tip away as it expands. We're using black flux, which withstands about 1400 degrees. If you use white flux, it's not as forgiving as black flux. It works just the same, but you have to be much more careful with it than you do with black flux. Sometimes it just wants to float away, and you've got to push it back in there. What we're trying to do is actually create what you might call an oven effect. We want to bring everything up to the same temperature so that we don't overheat it. And the solder flows uniformly all the way around the tip. What we're looking at is the back side of the blade, the bottom side, after brazing. We're looking to see if the solder flows all the way around the tip. We're looking to see if the flux is a uniform color where we haven't overheated it. We turn the blade up vertically, and we look at the teeth to see if they're straight and centered. And make sure that we have a good bond all the way around.